Kosuke is the creator of Jenkins and the CloudBee's Chief Technology Officer. He is a well-respected developer and popular speaker at industry and Jenkins community events. He's often asked to speak about his experience and approach in creating Jenkins, a CI platform that has become widely adopted and a successful community-driven open source project. In fact, KK is more like a rock star is what he is. The principles behind the Jenkins community, which are extensibility, inclusiveness, low barriers to participation, have been the keys to its success. And KK's sensibilities in creating Jenkins and his deep understanding of how to translate its capabilities into usable software have also had a major impact on CloudBee's strategy as a company. Before joining CloudBee's, Kosuke, or KK as we affectionately call him, was with Sun Microsystems and Oracle, where he worked on a variety of projects and initiated the open source work that led to Jenkins. KK.
Thank you. Let's see. So today I wanted to talk about, today I guess we are all talking about the continuous steadily for the whole day. For a techie like myself, the reason I'm excited about continuous steadily is mainly because it talks about automation, right? So that's there's all sorts of technology in this space that is working toward automating more of our work. So I think this is one of the reasons I think this effort is more real, as opposed to say some of the other buzzwords that didn't quite make it, like a SOAP, for example, which I used to work on. And obviously, my particular vehicle to agenda into this space is the Jenkins. And then so just as a context setting, for those of you who don't know about Jenkins, so it is open source continuous integration server. It's been in existence for close to 10 years now, depending on how you start counting. It's primarily implemented in Java, and it derives the value primarily from this extensive ecosystem of the plugins. Today, we're almost getting close to the 1,000. So I think 975 or something is the accurate count. And in fact, we are still seeing so many new plugins coming out that on average in a week, we see 3.5 plugins released on average. So every 1 in 2 days, and every other day, you're seeing brand new plugin released by somebody from the community somewhere in the world. I think another main value of the Jenkins is that it's, I think, they're capable of driving lots of computers, and then we sort of call it slaves for the purpose of driving them. It used to be that the dealing with large amount of computers is really only a problem for a chosen few companies like Google or Facebook. But thanks to the cloud computing and virtual machines, I think now every one of us will have to deal with those. So Jenkins kind of provides a convenient way for you to drive lots of computers and makes them do something useful. I think that's one of the reasons in this day and age the Jenkins is getting popular. Another emphasis in Jenkins product is placed on sort of getting started very easily. So to launch Jenkins, all you have to run is just this one command. And then you can spend maybe like 30 minutes, get it going, and then do some little things that's useful. And maybe in the following week, you might come back and spend another 30 minutes, and that'll make Jenkins do a little bit more. And then if you keep repeating this process, your domain of automation would gradually expand, and then your team sort of starts spending less and less time on the mundane things and more on more productive stuff. So another indicator of the growth of Jenkins, so we started, I think, around 2008, adding a mechanism for the Jenkins instances to report the usage statistics anonymously to our project website. And then we started tracking how many jobs aggregate people are running in total of all the instances that we are tracking. And then so it's been growing nicely. And then at around 2010, I don't know exactly what happened, but I think the more and more mainstream companies started using Jenkins in a lot more massive scale. So we started seeing a lot of growth. And now sort of it's close to the 4 million jobs are running on Jenkins around the world on, I think, the last count, 70,000 Jenkins masters. and that combined they are driving close to the 19,000 slaves, which is enough number of computers to fill a few data centers completely. So there's a massive amount of the resources spent on things automated on Jenkins, which I'm very pleased of. So perhaps the reflection of the fact that it's getting so popular, you can't really go to, did I skip one slide? Because I feel like I missed one. Oh, well. So perhaps the reflection of the popularity, you can't really go to conferences anywhere without hearing the name Jenkins mentioned a few times. So there's Amazon had a huge event in Las Vegas, and I'd imagine the AWS is a huge movement in the industry, so this was a huge event. And if you've been there, you have heard the Amazon engineer talk about Jenkins in the context of their, I guess, services. Or if you watch the Google Cloud Platform event live, so this is the Google's premier event for showcasing what they are doing for the, in competing with Amazon Web Services. And then you'd have seen the demo that shows Mr. Jenkins in his full glory like that, which is really unique for Google because they tend not to talk about what's happening inside their data center. That's supposed to be their secret, and they tend to hide everything behind the pretty UI. Well, in this case, they chose to highlight Jenkins because they realized the value of the ecosystem that this would bring. And it also made an appearance to their slide as well, so it's an integral part of what they see as the deployment pipeline in the Google Cloud Platform. And of course, another rage in this year is Docker, right? Like everyone, I think, again, I've already mentioned at least a dozen times today, Docker being mentioned. And so if you've been to DockerCon, which I think happened maybe 3 months ago in San Francisco, you'd have seen the Jenkins logo appear alongside the GitHub and the AWS and so on. So that's a huge product placement for us. And then another company called Rebel Labs did a survey, mainly among Java developers, asking how many people use what tools, and they discovered that around 70% of the people who do continuous integration does that by using Jenkins. And then the next one, I think, if you remember correctly, was Hudson for 8%, which is basically people who have forgot to upgrade. So between those two people, you could safely say that this is by far the most dominant CI server on the market. And to the point that it even showed up on a TV show. So in the US, there's this the TV channel called HBO. It's supposed to be a for-pay, very expensive, like a drama channel. And then they did this Silicon Valley show where it's basically a drama about the startup in San Francisco. So it's like a 5-guy in a garage, not quite in a garage, but hacking the code. And in one night, so in one episode, I think they're hacking on this new feature that has to make it until the next morning. I think they broke the production database or something before the launch. I forgot the exact story setup. And then so they're frantically coding in the night. And toward the end, so they discover, okay, so now I think the coding is done, and everyone will gather around the monitor and then watch the Jenkins sort of run the test. And this progress bar would actually animate in the video, and then they would bring to the completion, and everything turn into green, and everyone high fives. It's like a 4 a.m. in the morning, and they head back, and that's the sort of the end, the climax of that episode. So I was really surprised that so this is how popular it got over the last few years. So I think I mentioned about this huge plugin ecosystem, but I think that the part of the reason the Jenkins is very much relevant in the continuous delivery space is because it has a great integration with a number of technologies that are also important in this space. So I wanted to quickly touch on some of these integrations. So many people are using configuration management tools like Chef and Puppet. So as the domain of automation expands, we started feeling that we needed a better integration between those tools because often this is the handoff between developers and operation happens, and clearly we need a better integration in that space. So what we do is, so we recently added a feature that we call the traceability feature. The idea is that in the continuous delivery environment, you're supposed to be only building source code once and turn it into the binary. So when naturally Jenkins should do that, and what you can do is when the Jenkins should build the artifact, you can record what we call the fingerprints, as you see here. the fingerprints is actually just nothing more than the MD5 checksum, but because every build produces a slightly different binary, every time the binary is produced, they get a different fingerprints. And then the binary often leaves Jenkins into some kind of artifact store. Maybe it's a Nexus artifactory, or it could be just a directory full of files, or maybe it's S3. It doesn't really matter. But this is often then used as an input to the operations guy. So they have Puppet manifest or chef recipes that would then defer to these files, and then when they actually run on these computers, they get downloaded into the actual server. So what now this integration would provide is, by listening to what these tools are doing, then that's relatively easy to do because these tools are also extensible. Now, the Jenkins could actually learn what files are being deployed into the actual servers. And from there, by following back the check print, Jenkins could now learn exactly what file was deployed when and where. And then that means you know exactly what changes went in and so on. So that, in turn, enables greater automations. In the space of Docker, there's a number of plugins being worked on, but one of the useful and I think the interesting ones is the idea of launching Jenkins slave inside the context of the Docker container. So that allows you to create this known clean environment for running the build. And at the end of the build, you could shut down that and destroy that container and slave. So therefore, you can bring things back into the known clean state without worrying too much about keeping the environment clean or pristine. Now, speaking of the Git integration, so this is something that this is a feature that exists in Jenkins Enterprise by CloudBees. And traditionally, when you use the Jenkins as a CI server, the order in which you do things is that you locally hack the code, and then you push that into the repository, and then Jenkins would notice that the new commit landed into the repository, and then do the build. So that's the order in which things happen. So what that means is, if Jenkins discovers a problem, and then at that point, the damage has already been done. And it's great that the Jenkins could help you fix that quickly, but nonetheless, during a certain point of time, the repository is broken. So in distributed version control systems like Git, there is no reason you'd have to do things in this way. In fact, I think a much more sensible thing to do is for the developer to create commits and then push the change into Jenkins. So we made Jenkins speak the Git protocol, so to speak, and then therefore it's capable of receiving a commit, and then once it receives your commit, then it will run the sort of predefined set of tests and rules and whatnot. And then only after it's confirmed to be successful, the results get pushed into the team repository. So now I use this extensively while I hack on Jenkins core, and then this way I never have to run the entire regression test suite on my computer ever again. I basically just have to make sure that the code looks good enough to me, and it's not obviously broken, and then I just send it over to the Jenkins, and then totally forget about those changes and move on to something else. And in the meantime, Jenkins would do its own thing, run whole test, which takes about like an hour, a little bit over an hour, and then provided that everything works, my change is landed into the team repository, and everyone else can see it. So in this way, I'll be never ever accused of breaking the build, and that's a great achievement. Finally, after 10 years, so that's what this feature could do. So I mentioned about all this like a point integration that the Jenkins provide, and I think in fact this is one of the strengths. Is that in many large enterprises they have a peculiar set of tools or the processes that they already have established. So often the purpose of the Jenkins is not to be prescriptive about how you particularly do things, but rather sort of allow you to basically pick and choose exactly how you want Jenkins to behave in this existing environment. So Jenkins could be that. But at the same time, we discover that some of the people are sort of coming into this space brand new, and they're willing to change a whole lot to gain a substantial productivity boost. So if you're interested in more like a completed solution, there are also things that the Jenkins community does provide things like that you could look into to adapt as a basis. So as one such use case, I wanted to show how the Jenkins project itself uses the tools like Puppet and Docker and Jenkins to manage our infrastructure. So we do, we drink our own Kool-Aid, so to speak. So we do continuous delivery on our own infrastructure. So our infrastructure consists of hodgepodge of applications, mostly small, like account application, DNS server, LDAP, Drupal. There's a number of these little small applications that we are running, and we have to make some improvements to those over time. So the way we do that is, the way we put them all together is first by converting individual applications into a Docker container. So in that way, each application could be worked on in isolation, and then we don't have to worry too much about unintended interactions between them. So we have a number of small repositories that each consists of a little bit of source files to build the application, and also a Docker file that then turns out into a Docker image. So these, in our case, this all exists on the GitHub, and then they are hooked to the Jenkins. So every time the new push lands on the GitHub would tickle Jenkins, and then it will start doing the build, and then the resulting container gets pushed into the Docker image repository by using the build number as a tag. So every build is uniquely identified. And then there's another control repository, as we call it. So these are Puppet manifests. We use Puppet in Jenkins infra for historical reasons. And then, so they use, among other things, they point to various builds of the containers and say, okay, this IRC bot will go into this machine. The LDAP is going to go to that machine, and this is where the persistent storage is mounted from, and so on and so forth. So this is the ultimate recipe of how we deploy the infrastructure. And then for us to make changes to it, this is also hooked to the Jenkins, but in a slightly different way. So here, we make changes to this repository by creating a pull request on GitHub. And then we use this pull request building feature of Jenkins Enterprise like CloudBees. And so every time new pull request lands, we do the build. By build, we mean things like running unit tests, otherwise known as the RSpec Puppet. So it goes through, I think, the equivalent of compilation of the program. So it will make sure that you are not referring to symbols that do not exist, or you're following the coding standard, things like that. Basic testing that you can do without actually running anything. And then that would come back to the pull request as a feedback from Mr. Jenkins, whether this pull request has passed a test or failed a test. But obviously, if as a programmer, if you say, all right, we tested the code because it compiled, it's going to be a joke. So the same thing applies to the operation side. So for us to really test these Puppet manifests, we kind of have to run the whole deployment. So for that, we've combined the vagrant with the server spec. So this would launch the number of virtual machines on EC2 by using the same AMI that we use, copy over entire recipe and Puppet manifest, go through the entire deployment sequence, except that with the sort of dummy data. We can't use the production data for this. And then it runs through a series of tests to make sure that the service is actually running, things are in the good order, and so on and so forth. So this takes, so this is a real test. It takes a long time to run, and it costs a bit of money. But at the end of this, we have a better confidence about the state of these infra definitions. And then, so we have the actual production machines are deployed through the Puppet master. So this, we use the tool called R10K and then so whenever the change happens in the control repository, R10K gets tickled again with a webhook. And then so it will check out all the different branches as different environments into the Puppet master. And then all the machines on this side are hooked under specific environments. So they get automatically updated. So, for us, with this kind of setup, the deployment is basically a Git push. And then so we have two key branches here. So the branching strategy involves having a staging branch, which has a certain number of connected machines that are sort of automatically updated. And so the development will happen on the staging branch. So as soon as the pull request gets merged into the staging branch, we can expect to see that in the staging environment. And occasionally, if you're happy with the state of it, then we'd merge it down into the production branch. And then at that point, the changes become visible to the real server. So again, for us, this is the reason why the deployment for us is just git merge and git push. And it leaves the entire record and so on and so forth. So, one of the things we learned, one of the things we learned from users as we talked to them over time, is that it's sort of, as I mentioned, it's great that the Jenkins has all these plugins that allows you to combine them in just about any imaginable ways, but it still feels like there's you're sort of dealing with discrete pieces, and each plugin has some expected use case, so it's still up to you to see, all right, so this plugin wants to do it this way, and that plugin wants to do it that way, so this is how I'm going to combine it. So there's very sort of narrow, specific ways that they can be combined, and so that's a bit of a trial and error. So we started feeling there might be a better way to provide the flexibility that's necessary to build this kind of complex automation. Instead of assembling jigsaw pieces, can we make it more like a, the clay or Play-Doh that would bend to arbitrary shape? So that's what we started thinking about, and then we started talking to various people, and eventually we came to this effort that is called the workflow plugin. So this is probably the, from my perspective, this is the most significant effort that's going on in the Jenkins community this year. So there's a lot of details to talk about here that doesn't fit in my given time allotment. But the general idea in the workflow plugin is that it allows you to describe this choreography or activities as code. So so what this is, for example, a very simple workflow definition. But what it's doing is you're asking Jenkins, all right, so give me a new slave, and inside it, I'm going to need a temporary workspace, and I'm going to check out the code, and then 10 times I'm going to build something. So that's, you could imagine that to do stuff like that in the, this being a program language hosted on Groovy, it provides a high degree of flexibility. And then again, because it's hosted on existing Turing complete language, you have it's got a rich control flow statements, like a for loop, try finally block, that sort of things that are all useful for writing workflows. And also, it provides means for you to create abstractions. So you could abstract away your company's common build process into, say, reusable function or class, and then still in a way that allows certain degree of customization by subtypes and so on. So as a programmer, we already know how to do these things. It's what we do day in, day out, and now you can apply that into the Jenkins workflow definition. And not to mention, because this is a text file, you can create a meaningful diff between various versions. You could put this into a version control system. It's a lot more manageable approach to create more complex workflow. Another thing, as you saw, is that this is capable of not just coding into other jobs, but you could actually check out the code or run in the process and do the whole thing inside just one job. So it would allow you to drastically cut down the number of jobs and provide clarity into the visualizations. And since this is a fairly substantial new addition to Jenkins, we are also taking the opportunity to fix some of the issues that's otherwise difficult to do in the existing job types. And one of those is this program that involves long-running build. Probably many of you have test execution that spans over hours or even days. And you might know that when the build is going on, if Jenkins loses a connection to the slave, or if you needed to restart Jenkins for the purpose of upgrading a plugin, well, that's too bad, because the Jenkins would sort of forget what it was doing when it comes back up, and then so it declares the build be broken. So you kind of have to execute the test from the beginning all over again. And that's obviously a big problem if your test takes like 3 days to run. But in workflow, we are fixing that. So you can let things running on the slave, and then you can restart the Jenkins master, and when it comes back up, the Jenkins would still be able to reconnect back to the process and then figure out what it was doing. So you didn't lose the state of the ongoing build when the restart happens when it comes to workflow. In many people's environment, the workflow often involves some critical human checks and balances in places. So one of the users have presented in the Jenkins user conference that they do the continuous automated deployment so long as the changes are only in the code. But as soon as there's a change in the database schema, they don't deploy that automatically. They have to pause it, and then the humans, the DBA, would have to come in, sign off the changes before it could proceed to the deployment. So even though you might be able to automate more or less the whole thing, at various point in time, you still want the humans to make decisions. That's really the only thing that the humans are left to do in this century. So the workflow will be able to accommodate this kind of the long pause and human interaction natively as a part of the definitions. Yeah, another useful feature in workflow that we are putting is called checkpointing. So the idea here is imagine that this is your continuous delivery pipeline, and then each of the boxes is some type of sizable computation, maybe build, test, whatnot. So you start executing this pipeline, and then you would start running one step at a time or some of them in parallel. But as the workflow gets more and more complex, it's often inevitable that occasionally, for some random reasons, one of the steps would fail. Often for silly reasons, like perhaps the server was temporarily down, maybe the disk has filled up, there can be any number of these things. It's not possible to anticipate all of that upfront. So when the failure happens, what you don't want to do is to throw everything away and go to the beginning and redo everything, because that would waste much of the good work that has happened in the early stages, which was perfectly fine. So instead, what we let you do is we let you define a checkpoint, this black dot here. And so that is for you to say, okay, once it hits this state, this is a kind of good point to come back to. So with checkpoint defined, instead of going all the way back to the beginning, now you could pick arbitrary checkpoint that you want to restart from. And then it will basically resume from the point of the completion of all these things. So it will run the rest of the program, rest of the workflow, and then that would bring things to the completion. So the recovering from the transitive errors, it becomes a lot easier. So that is the kind of thing. So this last feature, the checkpoint, is something we are planning to put into the Jenkins enterprise like CloudBees. And so this is the kind of sort of enterprise features that we are trying to build into our distribution of Jenkins. So this comes with the professional support, and it tends to have a lot of security or the large installation-related features. And we have a booth in the back if you're interested in more about it. So, so that was a bit of a quick tour around what's going on inside the Jenkins community. So there's so we are building lots of interesting point integration with the technologies that matters in this day. And I think in larger enterprise especially, the fact that it is not prescriptive, it allows you to combine pieces in various ways would provide a great win for this software. And then also you can, but if you also want to see how other people are successfully deploying continuous delivery pipelines, you have examples to look at. And the use case that I showed you, the way we manage our Jenkins infrastructure, it's completely out in the open source. And I have to tell you that this putting things together between Puppet and then testing and so on, it took some non-trivial effort. But the end result is something now you could reuse as a basis. And I think that's a rare opportunity because most of these interesting Puppet and Chef use tends to happen inside some other company's firewall that you cannot see. But here you can see them all. And then finally, we are really working on this workflow feature, which plans to tie this orchestration together in one unified single way. And we are working, so the certain version of it is already available today, and we are working towards releasing this for the production level within this year. So that's basically my part, and so if you have any questions, I'd be happy to answer.
Someone must have a question.
All right. I don't mean to put anyone on the spot, so.
And I'll ask a lot of the questions, but I'm always interested in the answers. So, what do you think have been the three most valuable things that are Jenkins enterprise development?
Okay. So the one of the features. Well, thanks. I didn't ask him to ask that, but it sounds like I should probably pay him for that. Yeah, so I think the Git validated mode is one of my favorite features because I really use this day in and day out, and I really can't think my life without it. That's what enabled me not to break build ever, right? So I think the second one would be the template plugin that would allow people to create lots of similar jobs, but in a highly sort of abstracted way. And then this workflow checkpoint implementation is actually kind of cool, not necessarily because it's useful for you because it's not yet usable by you, but it's because the implementation is really sort of clever. All right, so I think that makes it three. And thanks for asking the questions. All right, I think that's it. Thank you.
Okay, our next speaker is Ben Woodhouse.